Bismillahirrahmanirrahim. We are still discussing the interpolation. And we define the interpolation to be the estimation or a method to estimate some new values based on some given range of data. And we discussed the Lagrange linear interpolation and Lagrange quadratic interpolation. And last time we spoke about the Newton divided difference, where that we need to find the divided difference as coefficient for the approximating polynomial. For the Newton divided difference, we said that if we have equally spaced data, values for x, then we can write the general formula for the Newton divided difference in a special way. And we gave example for the forward difference last time. And we said that the forward difference is given by delta fi equal to f of I plus 1 minus f sub I. Means it is the next value minus the current one. Today we are going to speak about the Newton backward difference formula. The backward difference is given by, like this upside down of the delta, fi equal to fi minus 1. It is the difference between the current one and the one before. For the forward, it is the next value minus the current one. For the backwards, is the current one minus the one before. So the backward difference given by this one, f of I minus f of I minus 1. And from this one, we can write the general form for the backward, or in the case, backward difference. Case, backward difference. Is given by fi is equal to k minus 1 I minus of k minus 1 f of I minus 1. So we can write the formula for this one, the Newton backward formula. Interpolation. Given by f of x approximated by Pn is equal to f0 plus r قبل f0 plus r multiplied by r plus 1. The forward it was r minus 1, but for the backward is r plus 1. We are adding this r plus 1 divided by 2 factorial of the square f0 plus, and keep going in this way until we get r multiplied by r plus 1 up to r plus n minus 1 divided by n factorial sub 0. So this is the backward formula for the Newton's difference interpolation. We are applying this if we have equally spaced values of x, when the difference between the xi are the same. R is given by x minus x sub 0 divided by h. Take one example for or to apply this formula. Compute 7 digital value or decimal value and decimal places value of the PSL function. J sub 0 x or x equal to 1.72. From the given table. As we have xi equal to 1.7, 1.8, 1.9, and 2.0. And zero at xi given by say 0.3979 849. For 1.8 it is 0.3399864. These are given in the question, and this is for 1.9 it is 0.2818186. For 2.0 I will have 0.2238908. We need to find the differences between these values since we have the difference between any two x is 0.1. So this is equally spaced. The differences between any two consecutive values for x is equal to 0.1, so it is equal. So this is equally spaced. It means that we can apply the either forward or backward Newton formula. This question I'm going to use, okay, let's use both of them. But first of all, we have to find the differences. This is the first difference. Let's find the first difference of these values. So I need to find the difference between these, the first one and the second one. Using the calculator to find the differences. Okay, for the first one, it is 0.3399 minus 0.3979849. I will have the first one will give me minus 0.05799 0.85. Second one, I need to find the difference between these two. Minus 0.058 1678. Now the difference between the fourth and third, minus 0.0579 278. What if I know now is just the differences? We didn't divide it by the difference of the values of x because they are equally spaced, and this will be included in the value of r. So if we have equally spaced values, no need to divide by the differences of the xi's. This is the first one. Let's do the second difference now. The second difference will give me, let's find the difference between these two. It will be minus 0.0001693. And between these two, I will have 0.000240. This is the second difference. We can move to the third one. So the difference between these two will give me 0.004039 or 93. Now, as we mentioned before, these are equally spaced. So I can do it either by forward or by backward. If we apply the forward formula, the forward formula, it is sub n x equal to x sub 0 plus r, the x sub 0 plus r times r minus 1 square x sub 0 divided by 2 factorial, and keep going in this way. And r is given by x minus x sub 0 divided by h. And in this example, r is equal to because x is the given value, is this one, 1.72. 1.72 minus 0.2. I'm sorry, minus 1.7, which is 0.2. This is x sub 0. 1.7 divided by h. H is 0.1. Which is equal to 0.2. This is for r. This is x sub 0, x1, x2, and x3. Let's say this is the forward. So the value for g sub 0 of 1.72 is approximated by P n, that is 1.72. Is equal to. Now for the forward, we say forward, we are going to use the first entry for every column. This is forward. We are using the first entry in each column of the JI or the differences. So this will be given by point 39 7 9 8 4 9. This is the first value there. Plus R is equal to 0.2 multiplied by the first difference. First difference is given by minus 0.00 or 0, only 1 0, 5 799 85. Now go for the second term, this one. Plus, that would be 0.2, this is R. And 0.2 minus 1 will be minus 0.8. This is 0.2 minus 1 will give me minus 0.8 divided by 2, multiplied by the second difference. That is this one is equal to minus 0.001693. Plus the third one, that will be R, which is 0.2 multiplied by minus 0.8 multiplied by minus 1.8 divided by 6 or 3 factorial multiplied by the third difference, so that will be 0.004093. And the value for this one will give me 0.386 4183. So this is if you apply the forward formula. Now for the backward, formula. For the backward, we are not going to use the first entry. So that for forward, it is x sub 0, x1, x2, x3. For the backward, what is there? Using this one. For the back, we start from the bottom. This will be x sub 0. This will be x minus 1, x minus 2, x minus 3. It is backward. So the first value will be the last one in the first column. This will be x sub 0 in the backward. It means that the R will be different. When we say that x minus x sub 0 over h, it is not the same R given in the forward. We have to go for the last one. So in the backward, R will be this x minus x sub 0 divided by h, which is equal to 1.72 minus x0 is equal to 2. In the backward is the last one divided by 0.1. And this is equal to minus 2.8. So we have to be careful about the value of R in the backward. This is one thing. Another thing, since we reverse the order of the X, we are going to use the last entry in each column for the backward. We are using the last entry in each column for the backwards. In this case, G sub 0, 1.72 approximated by Bn. For the backward, 1.72, which is equal to F sub 0 is the last one, the value of the F. So this is equal to 0.223890. This is the last value in that column. Plus first R, it is minus 2.8 multiplied by F sub 1, or the first difference, but I'm using the last one, is this one. It is minus 0.057927 8 plus 2. It is R and R minus 1, minus 2.8 or plus 1. Because for the backward is R plus 1. That will be minus 1.8. Multiplied by 0.0004. The second one. And for the last one, we plus over 6. This is over 3 factorial. It is minus 2.8 multiplied by minus 1.8 multiplied by minus 0.8 multiplied by 0.000409.3, and this will give me the value of 23864184. So this is the value for the Bessel function at 1.72. The first one gave me 0.38648183, and the second one is 0.386418.4. Again, using the backward, it's just a matter of reversing the index. If we say the forward, we start with the first one as x sub 0, x1, x2, x3. If it is backward, start from down. X sub 0 is the last one, then x minus 1, x minus 2, and x minus 3. And the coefficient of the polynomial, if it is backward, we are using the last entry in each column. If it is forward, we are using the first entry in each column. And now the main question will be, when do we need to use the forward or the backward? If you see the xi's, 1.7, 1.8, 1.9, and 2. And we have x equal to 1.72. Normally, if the value of the given x is very close to the beginning xi, we are using forward. Because 1.72 is very close to the start of the list, that 1.7. So it is prefer to use forward. And if the values, for example, x given, this is forward. Is prefer to be used. If x equal to, for example, 1.95, you can see that 1.95 is very close to the end. In this case, it is better to use backward. So depending on the location of the value of the given x, we need to find the value of the function at. If it is very close to the start of the list, then it is better to use the forward. If it is close to the end, then it is better to use the backward Newton formula.